Time starts now. Get in.
Okay, so good evening, ladies and gentlemen. We are Hibikino-Musashi Home from Kyushu Institute of Technology. So today, I would like to talk about HSR runs your preference in daily life using brain-inspired amygdala model. So in the near future, home service robot will work in every home. So in that case, what kind of knowledge is required for robot? So now let's take a look at one example. So in this example, operators will say, could you get chocolate drink? So please wait, the demonstration is about to start.
Okay.
Could you get chocolate drink?
Okay, I find the object.
So in this case, required knowledge is what chocolate drink is. So such a knowledge is common all over the world. So deep learning is good for this because there are big data for chocolate drink. So we use YOLO for object recognition, but training of YOLO include complicated annotation phase. So in our team, we use chroma keying for object data generation. So the generated object dataset can be used for training and YOLO, and our proposed method completely remove complicated annotation phase. Okay, so how about this situation? So please start.
Could you get that?
I cannot understand.
Now, operator says that, could you get that? So now, so HSR can do this. But on the other hand, in the case of human, we can estimate that from our experience. For example, if my roommate said to me, could you get that? I will deliver for him energy drink because I know he likes energy drink. So like that, so required knowledge is local and it depending on people or environment. So deep learning is not suitable for this. So in this case, robot has to obtain such knowledge through few human-robot interaction. So we focus on amygdala, which causes fear conditioning. And fear conditioning is kind of classical conditioning, which is famous for Pavlov's dog. So in classical conditioning, amygdala takes several stimulus at the same time and condition these stimulus. And after conditioning, conditioned reflex occurred by only conditioned stimulus. So we apply this classical conditioning for home service robot, and now we will show you one example of could you get that? Yes, please start.
What's up?
Could you get that?
The face is Yoshimoto. In living now. Okay, I look for the detail on your way.
So here is our proposed amygdala model. So our proposed amygdala model includes self-organizing map and perceptron. So this amygdala model obtains several information about ordered food using voice recognition, and the person's face using image recognition, and the place using slam. And such information input to self-organizing map, and self-organizing map classifies this information, and the classification results are input to perceptron. So in the perceptron, perceptron learn the relationship between the classification result and the ordered food. So this is a condition phase. And after that, if operator said, could you get that? The amygdala model estimate what he wants. So using the information of person's face and place.
Perfect. Here you are.
So here is a training of preference. So as you can see, some in the proposed amygdala model classifies the person's face, and the amygdala model estimate probability of that using the information of face and position. Could you get that?
I will look for cookie.
So the most important point is our proposed amygdala model can adapt by 4 or 5 human-robot interaction. That is a good point of our proposed method. Now you can see the probability of that is changing while the human-robot interaction.
Potato chips. I'm preparing to start.
Okay, so let me summarize our presentation. So our robot learned preference through human-robot interaction using the amygdala model implemented into our robot. So as future work, we aim to implement hippocampus and prefrontal area models to realize function of whole brain. So thank you for listening.